Hello everybody, my name is Aaron and today we're going to set up a solar array using 4 solar panels, a 48 volt battery bank, a regulator, and an inverter. I'll also be explaining how to do this with 12 and 24 volt setups. Welcome. If any of this information goes clear over your head, this is probably not the video for you. If some of it's a little confusing, keep watching. I try and do my best to explain everything. If in doubt, only set up one panel, one regulator, one inverter, one battery. I mean, everything as small as you possibly can. Don't try and go as big as you possibly can at first if you're just figuring things out. 12 volt setups are great and they're easy to understand. That being said, let's get started. Let's not have any unreal expectations here. You're not going to be able to get off the grid with a couple of panels. There's 8 behind me here. That's about 2 kilowatts. I'm not getting off the grid with 2 kilowatts. I'm not even going throughout a couple of hours with 2 kilowatts, okay? You're gonna need like 40, 50 panels to even begin to think about getting off the grid. And that's if you're using energy very efficiently. The way that most people use energy, you're not getting off the grid for 100 panels. It depends a lot on where you live. I live in Canada, southern part of Canada, but Canada, and so we only get a 5-ish hours of charging throughout a winter day, which is just not enough. There's just not enough sun there. So a bit of rule of thumb when you're setting up your solar panels, as direct as you can to where the sun's going to be. If you have a pivoter, great. And also the more shadow you cast, the more sun you're getting. Don't do it like way off and some weird angle to get some big shadow on a wall or something, because you're not getting real sunlight then. You want direct sunlight, but you also want it at an angle that casts a big shadow. Solar panel positioning is important if there's leaves or trees in the way, which the setup we're doing has some. So we're not going to pull full voltage at the beginning. You have to be careful if you partially cover a solar panel. So if the sun is not filling this panel completely, let's say it stops a little bit past half, you might not actually get any power out of that panel, because it might require almost all the panel to be powered in order for electricity to come out the other end of it, because it's got some of its own circuitry in here. So yeah, you have to be careful about shadow on your panels. Here we have a solar panel similar to the one that we're going to be using. Specs for solar panels are on the back. You'll need all that information in order to make an accurate judgment call on what regulator you want and what inverter you're going to be using as a result of that. Get yourself some fuses. You want to put inline fuses on every line coming from a solar panel. You want to put inline fuses going from your battery bank. You want dead man switches. You want all the safety stuff. You might think to yourself, well, I'm just having a little setup and it's not going to be that big of a deal. Why do I have to do all this safety stuff? First of all, I doubt your home insurance is going to cover you burning your house down because you're trying to set up a solar setup. So just that right there. But you could just make an honest mistake and do a wire backwards or something, and the fuse saves you thousands of dollars and a possible fire. So do the fuses, do the switches. You want a switch in there so you can turn it off, or so that it automatically turns itself off, like a breaker. The setup we're doing on this video is quick and dirty, and we're getting the fuses in the mail. So there is no fuses here, but you want fuses going to the regulator, coming from the batteries. Anywhere else you want to put fuses, the more the merrier, okay? I have 2 of these 250 watt inverters. They're stackable to 500. Actually, they're stackable to 750. These run on 48 volts. So you need an inverter that is set up for the battery bank that you plan on making based on what your regulator can handle. So when you buy stuff, you really have to have a plan first, because if you have a 24 volt regulator and your inverter's 48, you're not going to be able to pull power out of your power bank. Here is a cheaper regulator. This was 20 bucks, I think. This is a 12 or 24 volt regulator. It says up here 12 or 24 with the amperage of 20. I ran a few of these in the past. I was pushing quite a bit of current through them in parallel, and I stuck a heatsink on the back so that it would cool off, and it worked. They're probably not very efficient. They're probably somewhere around the 75%, I want to say, efficiency. There are better ones to get. Best way to do it is to find one hefty regulator to run it all. When you start getting into multiples, there's more variables, there's more places for things to fail, there's more places for things to light on fire. So you will want one regulator if you can, and one inverter on the way out if you can. Yes, 48 volts is best. That's what all the big professional companies use. I'm assuming if you get yourself a 110 volt solar regulator and inverter, it would be even more efficient, because you're not pulling a bunch of current to make the exchange up to 110 volts. But all the professional ones I've seen are 48 volts, and it makes sense. If you're down at 12 volts and you want to pull a bunch of power out at 12 volts, the rest of it has to come from amperage. And amperage is a lot of current that's moving. The more current you move, the more heat you produce. So your efficiency starts to go down and your wear on your stuff starts to go up. So higher voltage, usually better. So stick with the 48, do the 24 if you have to, 12 very rarely, only for automotive setups in my opinion. Bring a 12 around in case you want to hook it to a car battery or something. Let's talk about batteries. Now this is a different bank than the one we're going to be using in this video. This is just batteries aside I'm going to be using to help you out. Okay, we have a bunch of do's. All the batteries along the top you can use, including that battery right there. That is only 6 volts, but that's an RV battery. So you could have 2 of them to equal 12. This battery, this one, these small ones, don't use them. Okay, these are car batteries. That's a lawnmower battery. And those are batteries for battery backup UPSs for like computers and stuff. So the big question is, can I use a car battery in a solar setup? Well, yeah, of course you can. Okay, but you're going to cook it. You're either going to cook it or you're going to severely hold back your solar battery array, or you're going to possibly mess up the good batteries that are in your array. These are all marine, deep cycle marine RV batteries, okay? That one I purchased a long time ago and it's still running great. These were about a year old now, year and a bit, and they're still running great. You can check the wear on your batteries and if a battery is decent by doing a resistance check on a device such as this. This will be linked in the description as well. This does all sorts of stuff, including charges batteries, but that's not what you want to use this for right now. This can check the resistance of a battery. A battery has a resistance as you put electricity through it. This one is 400 milliohm. I just put ohm because it's hard to scratch milliohm into this. This is 400 milliohm. So this battery is on the verge of being not useful. The higher the resistance, the less battery you're getting. Let's check on another one here. This battery, also 400 ohm. So they're about the same deadness. These are 27 milliohms each, and that's 60 or 45. I can't remember exactly. But a good battery is as close to zero resistance as possible. Now, if you're up in the 1,000 milliohm mark, it's dead. Get rid of it. This little guy, which I thought was dead, is really good. I think it's 40 milliohms. And the same with this. This is a really good battery. If you have a battery such as this one that's getting up there, I could probably replace the acid and get this milliohm resistance down a little bit. I'm not sure exactly how much, maybe 100 or something. So if you really want to start saving money, you can do that. But when you're picking out a battery, let's say you're buying used, check the resistance of the battery. It's going to tell you more information than the owner who probably has had it sitting in the rain for 2 years. So why are deep cycle batteries better? These batteries are set up for capacitance. These batteries are set up for amperage output. To start a diesel truck, to start a car, to start whatever, a lawnmower requires a bunch of amperage to spin up the starter motor, which is a little electric motor. To light or to run a fridge, to run a freezer, a TV, you don't need a ton of amperage. So these focus more on capacity, or the amount of electricity stored. These focus on output, the amount of electricity that can be dumped at once. So your capacitance here is much less than here. These are meant to have a bunch of current dumped out of them and then charged over a few minutes of car driving. These are meant to be slowly charged all the time while you're dissipating them. So they have different ways that they're constructed. They have different ways of handling electricity. This is the best way. This you can do. You're going to suffer. You're going to get batteries that die faster. You're also going to get battery banks that don't last very long. You'll soon realize that my batteries don't even make it throughout the day, let alone charge up ready for night. So if you have car batteries and that's all you're using, great, do it. Don't expect it to be amazing. If you have deep cycle batteries, don't mix them with car batteries. You will only go as fast as your slowest player in a battery bank. If that's my slowest player, guess what? I'm having a crappy battery bank. So only use quality batteries with good resistance levels, with good capacitance. You will only go as far as the weakest battery in capacity, in charge, in discharge. It's all going to be the weakest battery in your lot. So this is the data for that unit right there. And the important thing that we need to see in this thing is the solar panel voltage. What voltage can it intake? Voltage of panel, less than 100 volts. Okay, so it's rated for 48. That's your batteries. That's how much amperage it can take. When you're looking at your regulator, these three values are what matter. So these three values have to line up with your solar panels. Here is my data from my solar panels. So at 30.6, 30 times 3 is 90. This could run all three panels. But we're not dealing with the small one. We're going to deal with the big one. And the big one is rated for 140. That's operating current and open current voltage. So if you're pulling directly from the panels, it goes 150. So 3 times or 4 times 30.6, you're looking at somewhere around, what, 120-ish volts. So we're well within range of that. Now looking at your amperage, our panels are pulling 8 amps, and we're putting them in series, not parallel. So we're adding up voltage in series, not amperage. So we're way above in amperage. I'm going to link to regulators down in the description. I'm going to link to literally everything you need down in the description, so have a gander. Just because I link to it doesn't mean that it's all going to be compatible and everything like that, because you're going to go for a 24, 36, 48 volt setup, whatever you end up deciding. So you got to make your parts work for what you want to do. So this would be the wire we would need for parallel. It is super thick, really high gauge. Here is a graph showing the runs that you would be using for thickness of wire. All right, so there's a quick graph right there. This is series though. So parallel you almost never use because you need thicker wire, it produces more heat. It's a little less efficient getting the energy to the regulator, getting the power to the regulator. The most efficient way to do it would be series. So in series, all the panels are plugged into each other and then 2 lines run back. You just have to be careful about your voltages. We're gonna hook up some solar panels on our personal battery array. Let's do it. So as you can see, we have all the wires dangling here. I'm going to plug them in series. So I'm going to go positive, negative, and they're going to add up voltages as we go along. So the best, this is moving and rickety. The best thing to do is to figure out which positive or negative you're going to send down the line. So the one I have here, so that would be a negative. So now I got to grab the positive from over there and plug them in. So I've got all the connectors done, which means that these 4 panels are now connected to each other. So we've got 1 plug on each side left. That's a negative, and the other side is a positive down there. And those are where we're going to run our wires from the garage out to the panels. We're going to run 1 positive, 1 negative. And so there's one thing to note here. First of all, I try to slip them in behind the panels because I know these are rated to be in the sun, but the less sun decay, the better. So I'm slipping them back behind the panels. Get them out of the sun, get them out of the heat. Also, one thing to note, if you ever wanted to take this apart, do not just pull these apart. If your whole system is running and then you disconnect that connector, because there's such high voltage here, I know it's not extremely high, but the arc potential goes up as your voltage goes up. So your arc potential here is fairly high. So if you were to unplug that while the whole system is operating, you could get a nice arc, light something on fire, or shock yourself or something along those lines. So the best thing to do is unplug the wires going to your battery bank or your regulator, and then unplug the panels. You'll have less arc potential. Don't get electrocuted. So the negative, if you're going to make your own ends or crimp your own ends like we are, the negative side uses this insert. And the positive side uses this insert. So don't screw that up like I did. It takes a long time to troubleshoot. this is the kind of thing you want to watch out for. So my strip wasn't exactly perfect, and so that's kind of coming out of the side. You want electrical tape and you want to fix that, because if that arcs onto this frame, it could start a fire. So you want to watch out for any breaks or anything like this. Cover it with electrical tape. So as you saw, I already got one end crimped. You only really need one package of these. Okay, so you need a positive and a negative, and that's all you need, because the wires that plug into the panels will be the ones with the proper connectors, and the wires plugging into the regulators are usually bare. There's usually a spot where you can screw them in, so it's usually bare. So obviously it's based on your regulator, how many of those connectors you're going to need. Maybe your regulator plugs directly into those connectors. Never seen it, but maybe yours does. The wire that you'll need, go to a solar place or get high gauge wire. You don't want thin wire. You don't want extension cord. Don't use extension cord. You're going to light yourself on fire. You need higher amperage, which means higher gauge. This stuff where I live in Canada, so it's going to be more expensive, is 75 cents a foot. Okay, and we're doing like 20, 30 foot runs. So it comes out to not that a lot of money to do it right. We are finished running our wires into the house. Here's our positive and negative, but they are actually backwards. Our negative is the red and our positive is the black. We plug them into the PV ports. Now I'm going to run a voltmeter on this thing first before we do anything, so I know exactly which is which, because I don't want to screw it up. As you can see, we are screwing another hole in the wall, and that's because we have two grounds down here that need to be run to the ground. So we're going to run the wires outside and down and spike them into the ground. So make sure you ground your unit if it needs grounding. And if it doesn't, you can still try and ground it. I have one panel plugged in. We're going to do a quick test, 34 volts. So as you noticed, the red on the voltmeter goes to the black, which means that the black is my positive, and the black here is connected to the red, which means that my red is the negative. If I were to do it the other way around, it would show a negative on the screen. So we have to wire everything the opposite colors that they're naturally meant to. So we have our wires into the box. We've got our positive, negative, and our ground wired in. Now don't let this fool you. The positive and negative are correct. Due to length restrictions, we ended up with the red as the negative. Okay, so let's head outside and I'll show you how we grounded it. Same window where everything's going in. We got a line coming out. Goes right down into the dirt. That's how we're grounding it. We're gonna pin it up against the house as best we can. We get another ground here for the inverters to go back to DC or to go back to AC. So you want to make sure your grounds are good and deep. This is our battery bank. We have 4 in series, so they add up as they go along. And I can prove you that by connecting negative over here, positive over there. We get 51.5, which is right in line with a 48 volt setup. The exact same thing happens up there. So we have one big battery that's 48 volts, one big battery that's 48 volts here, and now we're going to run a series parallel connection. We're going to connect the 2 series batteries here into one giant battery. That's 48 volts with a big capacity. While you're installing wiring, do one wire at a time. Don't have a bunch of loose ends hanging around, because you're going to lose track of one. It's going to touch and light everything on fire. Only do one wire at a time, only do one terminal at a time, and if at all possible, only use one hand at a time. If you have 2 hands in the mix, you could be shorting out something that you didn't even think you were shorting out. One hand if possible. Also, if possible, use tools that have rubber grips. I don't know how many times I've been using a ratchet or something like that, and the back end of a tool that's metal touches the other terminal, sparks everywhere. Use rubber covered tools. That's the best way to do it. So I have finished the battery bank. This one right here connects positive parallel. This one right here connects negative parallel. And the whole thing, we get 48 volts. Now, as you can see, I didn't mention, this is covered in baking soda. Threw baking soda down because topping up with acid and distilled water, you're going to get some spillage. Also, if at some point you get things bubbling over, they'll immediately get neutralized by the baking soda. But if it's left, you could corrode your connectors with acid. So I always sprinkle baking soda on top just to keep on top of everything. Okay, so we have our negative hooked up. I'm going to touch the positive here. This is what to expect when you are connecting the regulator. All right, so what that is the initial charging of the regulator's capacitor. So you get a high flow current, creates a spark. So now we've got to put the battery cables on. So this is the part of the wiring where everything is live because you're working with power already in a battery. And you have to be careful not to connect the wrong end because it'll just all melt. From battery bank to inverter, you're going to need the thickest cable you can find. Extremely thick. That's where all of the amps are coming from. That's where all the current's flowing into that inverter. You're going to need as big an open gateway as you can get. If you've installed your solar setup and everything's running great, put your hands on some wires. If they get hot, you need to change that wire out for a thicker wire. Hot wires are not good. Here's our done battery bank. We have the positive, negative lines going to our battery bank. Here's the positive, there's the negative. We have our solar coming in. They are both red, but don't be fooled, positive, negative. We are getting screen display here. I do not have the solar panel plugged in to power everything yet. We did the ground on our inverter, and we can tell the inverter works because there we go. So I'm going to go plug in a solar panel and we're going to give this a try. This is our grounding coming out of the garage. It's not the best ever. An electrician showed me once to put them in a triangle and then run a wire between them all. But for what we're doing right now, I think this is going to be just fine. They're stuck in the ground about a foot and a half. And then we're going to pin up the lines leading to the solar panels. Okay, so our unit is running right now. We have some branches in front of the solar panels, so we're only pulling 282 watts. We got to move some branches out of the way. We've got the battery bank hooked up, the inverter going. It's getting a little warm because we're running an AC unit through this extension cord running into the house. We also have the ground running out of here. Put the cap on here so that none of the ports would be touched. And we did a little easy programming with this. So far, so good. Some key points. It all depends on what regulator, what battery setup, what inverter you have. If you've already got something, run everything towards that. It's those specifications. If you want to run 24 volt, if you want to run 12 volt, 48, whatever, the higher voltage you get, the more efficient things seem to be as far as heat. And as far as buying really thick cabling, if you're running 12 volts, you got to run really, really thick cabling. The best thing to do, and the most common for the professionals to use, is 48. So you want to go 48. This stuff, I can link it all in the description of where to get all this stuff. This one is stackable, so we have two of these. We can stack them on top of each other, but that's another video later. You have to figure out what voltage of battery bank you're going to use before you can buy anything else. So what about you have a solar panel that's 12 volts and you want to skip the regulator, or you have a solar panel that's 24 volts, you want to skip the regulator 36, all these kind of things. Yes, in theory, I guess you could do that. But what's going to happen? First of all, batteries aren't exactly 30 or 36, 24, 48. They're always more than what the common term for it is. A 48 volt battery bank would probably be around somewhere around 54 through 56-ish, topped up completely. A car battery at 12 volts, it's actually not 12 volts. It's probably running at about 13.5 to 14 fully charged. And dead, it's around 11 to 10.5 to 11. Not going to be topping off your batteries if you're getting 12, 24, 36, 48 volt solar panel. You need a little bit more. But here's the kicker. The only time that you would ever be charging your battery without a regulator on one of those panels is if you're getting full sunlight. Because as soon as the sunlight drops off a little bit, your voltage is going to drop as well. So your battery bank running 48 volts, which is actually about 54-ish, the sun starts going down. Your panel's now only putting out 45 volts, 48. Doesn't matter if it's below 50, it's not going to be doing anything. So you've just annihilated half of your day by not having a regulator. So your panel puts out a certain amount of voltage and amperage. Your regulator can take the amperage and bump up the voltage using some amps. What'll end up happening is you'll be able to charge further into the day. Okay, you'll be way more efficient with a regulator. Thank you guys for watching. Don't forget to check out the description for purchase links for this stuff. Feel free to leave a comment, ask some questions. I'm not going to be able to answer everything. I don't know everything about everything. And If you know an electrician, that's the best person you can talk to. A lot of this is just figuring out your proper voltage and amperage based on the ratings of your regulator and on your inverter, as well as the solar panels. So you just make everything dance happy with each other and you're good to go. Thank you for watching. We'll see you guys next time. Ciao.